is find an equation for the circle that has a center at -1, 4, and it goes through the point 3, -2. Okay? So what we need to do with this is we need to use the center and the point they give us to figure out what the radius of the circle is. So do you remember how to find the distance between 2 points? Does anyone remember our old friend, the distance formula?
Something, the square, something.
Something, the square root of something.
Plus and minus.
You're basically taking these 2 points and you're doing the Pythagorean theorem with a -1, 4, maybe around there, 3, -2, right around there. So what you're going to do is you're going to make this into a right triangle and try to find the hypotenuse of that right triangle. Okay? So how would you find this distance right here? If you just knew that this was x2 and that's x1. The difference of the x's, right? So you would subtract the x's. So x2 minus x1. How would you find this distance right here? Right, y2 minus y1. And then to do the Pythagorean theorem, you have to do this thing squared plus this thing squared, and then that would give you the hypotenuse squared, and then that's why that's all underneath the square root. Okay? So on your own, will you, now that you have the knowledge that you need, figure out the distance between point C and point E. Okay? And let me know if you need help figuring that out. So that comes out to be the square root of 52, which Raina says 52 I know is 4 times 13. Square root of 4 is 2. So you can simplify that to 2 times the square root of 13. However, you don't have to do that because the formula for an equation of a circle, if you recall, is going to be x minus the x coordinate of the center. So x plus 1, because you're subtracting a negative, squared, plus y minus the y coordinate of the center, so y minus 4 squared, and that equals the radius squared.
Which is 52.
Right, since it's right. So
But isn't it half of that?
no, sir.
It's squared.
So the general formula for the equation for a circle is x minus, what did we call it, h squared plus y minus k squared equals the radius squared. Okay? So you plug that stuff in there and you're good. All right? Okay, anything else from B?
Number 3.
Number 3? Who would tell me what it is?
We're not recording, are we?
Patricia said we have to record every day, so we're trying to do it.
You may be.
Good? Okay. Number 3. Oh, good. So now we're going backwards. That's fun. So now we're starting with the equation. And we need to work through this and figure out what the center and the radius are. So we'll go the other way. Okay? So this is a little bit of completing the square like we did yesterday, because we want to get it to be x plus or minus something quantity squared, y plus or minus something quantity squared equals a number. So we're going to complete the square with the x's and the y's and go from there. Okay? Are you ready? All right, so I'm going to group the x's. X squared minus 6x, and I'm going to leave a space. I'm going to do that completing the square thingy. And then I'm going to have y squared plus 10y, and I'm going to leave a space equals -9, because I take the 9 and move it to the other side. And I'm going to keep going. Really fast. Okay? Yeah? No, that's for section 1.1 in the calculus book, which we're still not. But I've got to put something up there.
So we should read that one as well.
All right, so if I take the -6 and cut it in half and square it, I get 9. So I'm going to go plus 9 here, and since I went plus 9 on the left side of the equation, I have to go plus 9 on the right, down and out. And then I'm going to take this, cut it in half and square it, 25. So if I did plus 25 there, I need to also go plus 25 there. Okay? And now we are set. What does x squared minus 6x plus 9 factor into?
X minus 1.
Right, good. X minus 3 quantity squared. And this is going to be y plus 5 quantity squared. And these 9's cancel, so that equals 25. Okay? Okay? Like I said yesterday, whenever you take half of this number here, when you're completing the square, that's what's going to go to half of this number here, that's what goes there. Okay? So the center of the circle is at 3, negative 5, and the radius is 5. Because that's the radius of the square that we're about. Okay? Alright, anything else? Nothing happened. Everything's fine. It's a cell phone I took from a student that just went off. Not mine.
Tim, Ruthie, are you really that wide of that picture that you sent me?
I could, my phone's tuned down to take that picture. I have a really old phone, and so sometimes if I try to take a picture, it doesn't work, and I have to turn the phone off and then turn it back on, and it will work.
I think it was worth it.
But it just didn't seem like it was working. But I texted her later and told her. Well, it would have been better than texting. Yeah, no. Okay, did you need help with 4 or 5?
I didn't really try, but I didn't.
Yeah, that's fine. Okay, so we're okay with those? All right, how about part C?
Yeah, the part you did.
Yeah,
Part C.
I did.
2.
I just looked at.
Okay, yeah, you really need to be able to do number 1.
Okay, yeah, okay.
Okay, so let's just go through that really quickly. State the value of f of negative 1.
Wait, I actually did one, and I got it wrong.
Good. So the value of f of negative 1, you go to negative 1 on the x-axis, go down to the graph, and find out that the value is negative 2. Estimate the value of f of 2, so you again go over the 2 on the x-axis and go up to the graph, and that's about 3 or 2.8. Perfect. For what values of x is f of x equal to 2?
Is it okay if I got 2?
Negative 3 and 1, it looks like, so those are just going backwards. Estimate the values of x such that f of x equals 0. So in other words, where does it cross the x-axis? So around 0.5, maybe 0.4, negative 2.4-ish something. And state the domain and range of f. So the domain is the possible x values, so the x's go from, no, there's no arrows, the x's go from negative 3 to 3, and the range is the y's, and those go from negative 2 to 3. Okay? All right, so we're okay with that? All right, number 2 is going to become painfully familiar to you pretty soon. We're going to do this again and again and again and again and again and again. Let's listen to that. Again and all right, so we're going to do f of 2 plus h minus f of 2 over h. So all of this is easy except for f of 2 plus h. What do I have to do to figure out what that is? Cube it, yeah. So I have to figure out what 2 plus h cubed is. Okay, now you can do it the long way. You can go 2 plus h times 2 plus h, FOIL that out, and then take that and figure out what that times 2 plus h is. Cool kids. Remember Pascal's triangle, okay? Well, and I don't either because I did it wrong. This should
Look
be,
at some cheers in the bottom.
yeah, this should be 1 more than that. So this is anything to the 0 power is 1. If I took this and I raised it to the first power, it would be the first thing to the first power, the second thing to the first power. That's pretty boring. If you FOIL it out, you get that 2 turned to the middle, right? Don't tell me that there's some Zakistan trick again. Okay, all right, you're looking at it right. Okay, so 1331 means that it's 1 times 2 to to the third, right, times h to the 0, plus 3 times 2 to the second times h to the first,
You have to use
plus
parentheses.
3 times 2 to the first times h to the second, and I'll explain this in a second if you're totally lost, plus 1 times 2 to the 0, hold on, times h to the third, okay? So the 1, 3, 3, 1
We did the other way.
is the coefficients, okay? And then it's the first number to the third power, then the second power, then the first power, and the
Now you go
0.
backwards.
And then these go backwards. It's 8 to the third, to the second, to the first, and to the 0. Okay? Yes. Why are we doing it at all? Oh, cubing it? Because you have to take whatever's in the parentheses and plug it in for the variable here. Okay? This is h to the 0, then h to the first, then h to the second, and then h to the third. Okay? Yeah, it's probably easier if it's just a cube to go the long way. You just go 2 plus h times 2 plus h, and then multiply that answer by 2 plus h. But, just for fun. Okay, so h to the 0, I know how that would be trust me. That's going to be 1. So 2 cubed is 8 times 1 is 8. 2 squared is 4 times 3 is 12, so that's going to be plus 12h. 3 times 2 is 6h squared. And 2 to the 0 is gone, so that's just going to be plain old h cubed. Okay? So that's what that thing is multiplied all the way back. Okay, that was the only hard part of this problem. Now we have to go minus f of 2. So if I plug 2 in there for x, I get 8. And then this is all over h. Okay, what can I do on top? Cancel out the 8, so that leaves me 12h plus 6h squared plus h cubed over h. What? Oh, you want the higher power first? Yeah, you can do that. Okay, only because there is an h in every single term here, I can cancel this h with one h from all of these things here, okay? Please do not ever make the mistake of saying h plus 2 over h, the h is canceled and that equals 2, okay? That is absolutely not correct, okay? What's that?
The Jefferson method from last
The
year.
Jefferson method from last year.
Yeah.
Right. I've just made that up. Don't do this. That's wrong. Okay? So since there was an h in each one of these terms, essentially what we did is we factored out an h and then the h is canceled. So 12 plus 6h plus h squared. Okay? That's not the answer? Did they write it in the other?
Wait, hold on. No, that's the answer.
That's all you.
Phew! All right, what else from section C? 3? All of them?
Oh, wait.
Should we just kind of roll on through here?
Yeah.
What day is today?
The rest of these.
Thursday. So this could work out if we review today and we review tomorrow and then
And then
we'll
we
start
get started on Monday. I like that.
Ease back into it.
Ease back into it. Well, it's really important to make sure you guys know this.
Just jumping right back into it. It's not easy.
Yeah.
Just
Everybody knows this.
public service announcement, just in case you're curious.
Yeah, I'm with who?
That's funny.
That sounds kind of hard.
What?
What did Piglet say when he looked in the monitor? I see you. Piglet. All right, so 3A, they want us to find the domain, right? Okay, so what we have to do is we have to figure out what x values the function cannot take on. And there's only two things that you have to worry about. What are they?
When
Nope.
things dividing by 0.
No dividing by 0 and
No.
square root. Yeah, no negatives under the square root. Is that what this means?
Oh, no imaginary.
Right, no imaginary numbers. Okay, so no square roots here, so we don't have to worry about that, but we are
I
dividing
don't
by
think it can be
something.
1.
So we need to figure out what values of x would make this be 0, and then it can't be that. So x squared plus x
negative.
minus 2 cannot equal 0. So what Raina's doing is factoring this in her head, maybe.
No, I
it's just,
You're just plugging in numbers,
Yeah.
just guess and check. Okay, well, the easy way to do it is to factor. What does it factor into?
Plus 1.
Plus 2 minus 1. Okay, so that means x cannot equal what?
-2.
-2 or 1. Okay, so technically the way you would write the domain is the domain would be from -infinity to -2. Can't include -2, so I'm using a round bracket there, and then also from 1 to infinity. Okay, so that's your domain in interval notation. Okay, I'm comfortable with that. That doesn't bother me. There's some things about me that are getting worse that bother me, but that's not me. Well, you know, because you've had my class before, my theory about the afterlife.
Oh, the movie?
No, yeah. You get to just, when you die, you get to have all the questions that you've ever asked in your whole life answered. So, like, you get to find out what dinosaurs really look like. You know, things like that. And one of the things I get to find out is how many times in my life have I written the word X?
We did one day,
think
or like,
we kinda did a math problem.
We did a little
Then
bit
what
of
happens
math.
once you run out of questions?
Well, in my little theory, then you have learned from that, and then you
Well,
can go
you
back
get to
and
ask
try
that
again.
question too. What happens when I run
So
out of
you have,
questions?
you've learned from your mistakes, and you sort of know. And you know how some people seem like old and wise even when they're little,
Yeah.
and then there's some people that are old, and you're like, you are
Yeah.
really stupid. Well, that might be their first time around, and they haven't learned.
or they didn't have very many
So-
questions.
Or they didn't have any questions. Yeah. So ask as many questions as you can. Bring
So,
your life forward.
Abraham Lincoln probably asked a lot of questions.
And I'm just making all that up, so don't be offended. That's not a real actual.
Let's start a religion based off that.
That's not a real actual thing. I'm just being dumb.
Question asked.
I think if I died and I could have anything I wanted, that's what I would want. Yeah, that's it. Maybe that's how the religion will start. We'll watch the YouTube video and then.
Crazy back.
No, that'd be creepy.
We get so many followers.
Okay, back to the math. We have a root now, but it's not a square root, it's a cube root, right?
Then we get some
And
extremes.
it is legal to take the cube root of a negative number. So we don't have to worry about that cube root thing. That's not going to restrict the domain at all. How about the x squared plus 1? But it's not the difference of two squares, it's the sum of two squares. So will this ever equal 0? No, because this is always going to be positive, and a positive plus a positive is also going to be a positive. So my domain here is, whoa, is all real numbers. Okay? Okay? Well, now I'm really self-conscious about mine. Because through a
Look at that, I'm not even looking down.
Gavin is what?
I'm a bad person.
At least you can do it after some paper sideways.
You make an 8.
No, I'm pretty good at it.
He also is good writing.
Yeah. Oh,
Okay, so now we have some square roots, right? Right?
What is
Okay.
that?
That's a plus.
I know, it's just a -1.
Speaking of horrible handwriting. Okay, so 4 minus x, I need to make sure that I never have a negative number underneath there. Bigger or equal to not 0 because I can plug in 1 and I'm okay. 4 minus 1 is 3 and that's still positive, right? So from this piece right here, I know that x has to be greater than or equal to 4, right? I'm sorry, not greater than, less than. Yeah. Less than. If I get bigger than 4, then I'm going to end up with a negative number. Okay? This is a little trickier here. That is a difference of two squares, yeah, so we could factor that as x plus 1 and x minus 1, which means that it would, x would equal 0 when x equals 1 and x equals negative 1. So I'm okay with that. So do I need to make sure that x is not bigger than those, or smaller than those, or in between those, or what's my problem here? What's that? X can't be smaller than what? Can it be smaller than negative 1?
It has to be smaller than the smallest one.
It has to be smaller than the smallest one, and can it be bigger than positive 1? Yes, so where's my problem? Right, in between negative 1 and 1. It can't be in between those two numbers. Okay? So my domain for this would be from negative infinity to negative 1, and I'm fine. And then I have to skip everything between negative 1 and 1, because if I plug in like 1/2 here, that would be 1/4, and 1/4 minus 1 is negative, and that's no good. So then I'm going to go from 1 to 4, because that has to be less or equal to 4, and then I am done. As soon as I... Oh, yep, thank you. Thank you. Square bracket there. Okay. What about here? Would these be square, or should they be open?
No.
Can it be 1?
Yes.
Yes, so that means that these should also be square. Sorry, I made it this way. Just for your convenience, actually, just want to make sure that you don't need to get up and do anything. I was going to bring you, some French fries, halfway through, and go over. It's be nice to Ashley. Okay, so we're going all the way here, huh?
4K4 is easy. This is using calculator.
The rest are easy?
Number 7.
Okay, so just real quick, if you take y equals negative f of x, what does that do to the graph?
I can do the rest.
Flips it over the what? The x-axis, right, because these are all the y values, so the y values that were positive become negative, and the y values that were negative become positive, so that reflects it over the x-axis. Y equals 2 times f of x minus 1 does what? Vertical stretch of 2, or vertical dilation of 2, and what does the minus 1 do? Everything moves down 1, good, and then y equals f of x minus 3 plus 2, since the minus 3 is in parentheses, I move it to the right 3, and then up 2, okay? Okay, were you guys okay with the making sketches of those graphs? Do you hope so? Some of them are a little tricky, maybe.
It's like calculator.
It says without.
No.
No, so without using calculator. Okay, so I won't go through those because you can obviously do those on your calculator yourself, or you can just look at the answers that are right below it. But the key there is that you should sort of be familiar with what those graphs look like without having to look at them in the calculator. You should know what a parabola looks like, what an x cube looks like, square root function. Yeah, that y equals negative 2 to the x, a negative exponential function is a little bit odd. And y equals x, where y equals 1 plus x to the negative 1, that comes from y, or 1 plus 1 over x, right? This x to the negative 1 is 1 over x. And so you should know that the 1 over x thingy looks like this. And the plus 1 will just move that up. 1. Okay? Maybe we can do some calculus tomorrow. Really fast. I am not going to ever care what day of the week it is.
Friday though.
I'm never going to care what day of the week it is.
It's match day for golf. You don't
You
really
have
get
2 days to recover from your game, Evan.
But it's also a hassle because on Saturday I have plans and then on Sunday it's just Sunday.
Yeah, I have plans on Saturday, so don't.
You guys are sick. I know you're just teasing me. Okay, so for 6a, if you evaluate f of negative 2, which one of these two things do you plug it into? The first one or the second one? The first one, because negative 2 is less than 0. So negative 2 squared is 4, and 1 minus 4 is 3, so that would be negative 3. 1 minus 4 is negative 3. And then f of 1 would go in the second one, and so that's going to be positive 3. 2 times 1 is 2 plus 1 is 3. Okay, so that's the easy part. The harder part is to sketch the graph. So what does 1 minus x squared look like? A parabola, because it's x squared. It's upside down because it's negative x squared. And it's moved up 1 because of the 1. So I want x is less than 0 here. So that's going to roughly look like that. Okay? So that's the left half of an upside down parabola that has been moved up 1. Okay? What does 2x plus 1 look like? A line. Y-intercept is 1, so we're going to start up 1, and the slope is up 2 over 1, up 2 over 1. Thanks, man. So that turns out to be a continuous function. It's a piecewise function because it has 2 pieces to it, but it's a continuous function because they meet right here. The value at 0 is the same in both of them. Okay? Gabe, what was your question?
No, I was just wondering, I don't remember.
Did I answer it inadvertently? Okay, and then 7. What's that?
I don't remember.
You don't remember how to do that because that's not a time symbol. That's a composition of it.
That's how you put it into the.
Yeah, exactly.
I like to write it as F of G.
So you like to do it like this? Like that?
Yeah.
Okay. So F open circle G means F of G, and sometimes it's easier to use this notation because it really does give you the sense that you're taking the G function and plugging it into the F function. So I'm going to rewrite the F function, but every time I see an X, instead of writing X, I'm going to write the entire G function instead. Okay? Because I'm plugging that in for the variable. So X squared becomes 2x minus 3 squared, plus 2x becomes plus 2 times 2x minus 3, and then minus 1. Okay? Did they give you the answers in full simplified form, or is it just like that? They FOILed it? Okay, so you can FOIL that if you want. I'm sure you can all do that. Okay, so B is the other way around. B of f of x. So now I'm taking the G function and rewriting it. And then same thing, every time I see an x, I'm going to plug in what f is instead. So that is 2 times x squared plus 2x minus 1 minus 3. And then you can simplify that also. Okay? All right, and then C, I think I've ever done this before, G of G of G. Pretty awesome. What's that? No. Okay, so first I'm going to figure out what G of G of X is. So I'm going to do this thing right here. So I'm going to take 2x minus 3. This is like inception.
And then you put 2x minus 3.
Yeah, so I'm putting 2x minus 3 in for itself. So this becomes 2 times 2x minus 3 minus 3. And I am going to simplify that so that I can plug it into G again. That's going to be 4x minus 6 minus 3 is going to be 4x minus 9. And now I take that and put it in for x in the G again. So 2 times 4x minus 9 minus 3. 8x minus 1. Okay? Yeah, maybe we can get through this and start calculus. No better thing to do on Friday morning.
I can name a few other things.
Okay, do you remember how to convert from degrees to radians?
Yes.
180 over pi.
Is it 180 over pi?
180 over pi, yeah, if you're converting to
It
degrees.
depends which
And
way you're
then, right,
going.
pi over 180 if you're converting to radians.
Okay, yeah.
Okay? Okay, so same thing for number, so, yeah. Right. So if you have degrees, then the degrees go on the bottom so that they'll cancel and you'll be left with radians. If you have radians, then the pi goes on the bottom, so those are canceled. Okay, so that's 1 and 2. How about number 3? Were you able to do that?
Isn't it radians times radius?
Yeah, the formula for arc length is really, really simple. It's the radius times the angle. The only thing that you have to be aware of is that the angle has to be in radians. So for this, since they give us an angle of 30 degrees, you have to change that to radians first by multiplying by pi over 180. So 30 goes into 180 6 times, so that's pi over 6. And so the arc length is just going to be 12 times pi over 6, which is 7. Ooh, we definitely need to do 4. I've got to get rid of this.
I know what it is.
Do ya?
I did them a lot.
All right, number 4. We want to find the exact value of the tangent of pi over 3. Since it says exact value, that means you can't just put your calculator in radians and type that in. I'll give you some wacky decimal. You want the square root thing, okay? So I'm going to draw my reference triangle. Okay? Pi over 3 is how many degrees? 60, because 3 goes into 180 60 times, right? So I'm going to end up with a 60-degree angle right here. Remember these? Did these sort of towards the end of the year? Sort of. Okay, so I have my old friend, the 30, 60, 90 triangle.
Yeah.
What are the sides of the 30, 60, 90 triangle?
X, 2x, and x.
Okay, so we need with number. You want to go, you want to make this 2, make this 1, and make this root 3? That should do it to me? Okay, that's fine. Okay, then you remember what? 138. You guys are so, what are you, wow, time flies when you're having fun.
Let's
You
get
have to
out
quit
of
reading
here.
quick.
Just use
Yeah.
Well, I'm gonna have a new calculus tomorrow.
Okay, so then you remember your old friend Sokotoa. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if this is my angle, the opposite side is root 3, the adjacent side is 1, so the tangent is going to be root 3 over 1, or just root 3. Okay? Does that kind of ring a bell?
Yes.
That's an important one. That's a good one. We're going to play with that. You know, you kind of need to know how to do that. Yeah, we will, just for funnies. Okay, 7 pi over 6 is not quite so easy to convert to degrees, I mean, in your head. So 7 pi over 6 times 180 over pi. Pi's cancel, 6 goes in there 30 times, and so we're looking at the sine of 210 degrees, really, right?
Is that what's that thing where it's different? It's the something angles.
Coterminal angles?
No. It's where like it's 210, but it's a certain degrees off the axis, so you can use it. as a
Yeah,
different
reference triangle?
Yeah.
Okay, yep, that's what we're going to do. So 210 degrees is, yep, 90, 180, and then I have to go, like Raina said, 30 degrees more. So really what I have is just a little mini 30, 60, 90 triangle. Okay? And Taylor also said it, make sure everyone know that.
Raina just said it.
Well, Taylor said that it was 30.
Okay, yeah, so we're really using a 30-degree triangle. The only difference is that since we're in the third quadrant, this, well, let's do the easy one. This is not going to be 1, it's going to be -1. And this is not going to be root 3, it's going to be negative root 3. Okay? So now, once again, SOHCAHTOA sign is opposite over hypotenuse. The hypotenuse is always positive. Okay? So opposite over hypotenuse is what?
Negative 1/2.
Negative 1/2. Okay? Okay, we good with that? Blue Mas? Gonna do this one because it's not it's not sine, cosine, or tangent, so what the heck? Okay. Okay, so if I'm going to convert that into degrees, I have to again multiply by 180 over pi. So those cancel, not yet. So that's 60, so that is 300 degrees. So that's going to be a what? I think so, yeah. I don't know. Find out. Okay, so again, 90, 180, 270, and then I'm going to go 30 degrees more. And so, yeah, just remember that you're always drawing your triangle to the x-axis. So this is 30, which means this is 60. So we have a 36. So you were right. Yeah, so we have, oh, because you can just think of it as being negative 60. to negative 60. So this is 2, this is 1, and this is negative root 3, okay? So secant is the inverse of what?
Cosine.
Cosine. So yeah, so cosine is adjacent over hypotenuse, which in this case would be 1 over 2. Flip that over, and you get 2 over 1 or 2. Okay? Why are there children in the hall?
Maybe they're getting back now.
Okay, first.
Glad you brought them.
Seems like there's a lot of people outside. It does seem, I checked myself, is it really 11:30? You guys go back and pick with us over?
This is all sophomores. If there are any sophomores out there who will not have participation, now is the time.
I wanted to learn this period.
Okay, how do we do with number 5? Express lengths A and B in the figure in terms of theta. So what do you do with that?
It's fun. This is fun data.
So, right, exactly. So you look at the thing and you say, okay, here's theta, and then we don't care about the 24, we only want the A and the B. So this is the side that is opposite. This is the side that is adjacent. So you remember that that's tangent. So the tangent of theta is the opposite side over the adjacent side. So how do you solve that for theta? Nope, we're not. We're going to have an A and B in our answer. Yeah, you just do the arctangent of both sides or the inverse tangent. So theta equals inverse tangent of A over B. On 5. Oh, they do one.
Because there's a 24 on that.
Yeah. Right. Oh, expense the lengths of A and B in terms of, okay, so we're supposed to figure out this. So we want A, what does A equal and what does B equal? Okay, all right. did it backwards.
So it's
Okay.
24.
All right, so this is 24. Okay, so if I go A and the 24, that's the what and the what? Opposite hypotenuse, which is sine. So the sine of theta equals the opposite side over the hypotenuse. So okay, so if I solve that for A, what do I do? Right, multiply both sides by 24, so it's 24 sine of theta. I'm sorry, I went the other way around. And then this one is obviously going to be 24 cosine. That's okay. Got it. 7B. You want to do 7A also?
Oh, good lord.
Identities. You want to just do 7B?
Forgot all the identities.
You're especially not going to be good at identities because this has a double angle identity in here, and who in the world remembers the double angle identity? No. Anybody remember the sine double angle identity?
Isn't it like
Yeah.
sine A, sine B?
Oh no, this isn't the special formula. What we're doing is we're going to show that this side is the same as that side. Okay. Do you remember it?
Yeah, remember?
Yeah.
It's like sine A.
So not so much?
Yeah, no, I get that there's some,
Okay.
yeah,
Fundamental identity is on page very, very bad. Double angle formula, sine of 2x equals 2 sine x cosine x. Okay? So you can take this and rewrite it as 2 sine of x times the cosine of x. And then 2 tangent of x over 1 plus tangent squared of x. Anything fun that you can do over here that jumps out at you?
oh no, but I just nailed 7A.
Tangent is sine over cosine, yep. So you want to change all those into sine and cosine?
Yeah, you need to.
I need to? Okay, so I'm going to take the top one and change it into 2 sine of x over cosine of x. Now I'm going to do something fun with this here.
What does that equal like?
Yeah, because you know that sine squared plus cosine squared equals 1. So I can get tangent squared by dividing everything by cosine squared, right? So that would be tangent squared, cosine squared over cosine squared is 1, and that's going to equal 1 over cosine squared, which you could write as secant, but since we're changing everything into sine and cosine, I'm just going to take 1 plus tangent squared and rewrite it as 1 over cosine squared of x. So now we're pretty much done. Yeah, multiply by the reciprocal of things and cancel, and it'll all work out. Right? Then we take this and multiply it by cosine squared of x over 1. So this cosine cancels one of those, and I have 2 sine cosine equals 2 sine cosine. Are we done? Is that it? We're good now?
Okay, now, if there are any juniors who haven't had a picture
That was
taken,
fast.
please go.
What time are we done? 30? Oh,
They'll be starting the seniors any minute.
okay, so you guys don't have any more questions on any of these things?
We should have had more people. What about number 6?
Number 6, you want to do that real quick?
Yeah.
You don't know what's going on anymore? Okay, so sine of x is equal to 1 over 3. Then I'm going to go opposite is 1, and that's 3, right? Okay. I'm not really sure. I don't even know. We're leaving out the sine of x plus y. the answer is 115 times 4 plus 6 root 2. We got that. Okay, so that's what we know from there. So we can figure out what this side is here, right? If we wanted to. Because this squared is 9, that squared is 1, take the square root, so this is going to be the square root of 8.
Isn't there a formula for sin of x plus y?
Probably, yeah.
We need to do that.
We need that, okay. Let's just keep going here and then we'll look up the formula and use that. Okay, then if secant of y is 5/4, secant is the inverse of, you're spending way too much time looking at the clock. Secant is inverse of cosine. Cosine is adjacent over hypotenuse, right? So this is hypotenuse over adjacent. And so this is a 3, 4, 5 right triangle. Okay, good. So we've got that all figured out. Now we need to use this to figure out what the sine of x plus y is. So how do we do that?
Yeah, there is one.
Are you looking at the book? Oh, she's just trying to.
There's a sine A.
Sine of x, oh yeah, it is. Okay, so it is sine x cosine y plus cosine x sine y. Okay, is that what you're remembering? Okay, so this is plus, this is plus. Yeah, if it's sine of x minus y, then it's sine x sine y and cosine x cosine y. Okay. All right, so to figure this out, we need to know the sine of x. Well, if you look at our triangle, opposite over hypotenuse is 1/3. And then we need to know the cosine of y. So adjacent over hypotenuse is 4/5. Plus the cosine of x is 2√2/3 times the sine of y, which is 2√2 that's a 3. What is the sine of y? 3/5, so that's going to be. We do, right here. So that's going to be 4/15 plus, here the 3's cancel, 2√2/5.
Wait, what?
Did I do that wrong? I'm going fast, I feel like I made a mistake somewhere. This is cosine of x, so that is adjacent over hypotenuse 2, yep, and then this is sine of y, opposite over, okay, so we're good. So they got a common denominator or something? Or
Well, if you don't cancel the 2, yeah, you can't get that.
okay, and then what else happens after that?
Adding together with this 2, 1, all.
And no, because I can't add these together because they're.
Oh, and then you just take the.
How'd you get 6?
You just take the.
Because I went this times 3 to get a common denominator, so I have to go that times 3.
We can just take out the.
And I just take out the 1/15 for some random reason,
Yeah, then you got the.
and then that's the answer. Okay. I don't know why they wrote it in that form, that seems strange, but they did. Okay?
I'm just going to leave it.